Hello everyone, my name is Emanuele Giuseppe Esposito, and in this demo I will show you how we can leverage RHEL confidential virtual machines to secure AI workloads on Azure. More specifically, we will see how a fraud detection model running on a RHEL Azure confidential virtual machine is able to safely download, decrypt and store two datasets containing credit card transactions using confidential computing. Let's first explain what fraud detection is. This model aims to detect fraudulent transactions based on some details related to each operation performed. Geographical distance from the previous transaction, price compared to the median user transaction, and whether the transaction was executed using the credit card chip, PIN number, or if it was an online purchase. Based on this data, the model outputs the likelihood of a transaction being fraudulent. The goal is to safely run this model to perform offline inspection of transactions stored into separate datasets. Because the credit card transactions are very sensitive data, we need to provide great care and protect them while they are in transit, stored and used. In order to achieve that, we will use RHEL confidential virtual machines on Azure, which provide data in use guarantees as the memory is encrypted by the hardware. We will use attestation to prove that such guarantees are in place and decrypt the datasets only if everything is running correctly. The workflow is the following. The model needs some transaction to process. The data will be stored in two remote storage environments. One dataset in Azure Blob Storage and another dataset in AWS S3 bucket. The dataset, however, are not stored in plain text. They both are encrypted before being uploaded to prevent anyone from being able to read them. Well, where is the key to decrypt them? The key is stored in the Trusty, our remote attester running the user secure environment outside the cloud. So the encrypted datasets will be downloaded in a confidential virtual machine. And as said, we will use remote attestation to ensure that all security measures are up and running in the confidential virtual machine. The operating system is RHEL, hardware is actually encrypting the memory, and so on. If Trusty returns the key, it means that we are running in a safe environment. And we can decrypt the dataset and feed them to the model. Let's look at the actual demo. Let's start with the setup. In the Azure Web UI, we can see that we just created a confidential virtual machine running RHEL 9.5. The instance type is standard DC2 ES, where the C stands for confidential, as I will show you later, and ES stands for Intel TDX CPUs. Indeed, in the Azure documentation, we can see that DC family sizes are confidential virtual machines using the Intel TDX technology. Scrolling down, we also see that encryption at host is enabled, meaning that the root disk is encrypted. Let's now log in into the virtual machine. We can see that the Jupyter notebook running the actual demo is already started. The notebook port is also exposed to this laptop, so we are able to access it through a browser. In a separate virtual machine running on a secure environment outside the cloud, we also already started our remote attester, Trusty. The remote attester was already configured to contain the key to decrypt the datasets, as we can see here. Let's go into our notebook. We already downloaded the fraud detection guide and the actual fraud detection model. Because this model is created and trained with public instructions and data, it is not necessary to protect it. It doesn't contain any sensitive information yet. First of all, we check that the disk is actually encrypted. This gives us data at rest security, meaning whatever we download is stored in an encrypted disk, and even if it is virtually or physically mounted externally, nobody without the encryption key will be able to see what is inside. we can indeed see that the root is encrypted. Now we decrypt the dataset. In the Azure Web UI, we can see the first dataset called dataset1.csv.enc, and in the AWS Web UI, we find the second dataset, dataset2.csv.enc. The datasets are encrypted before being uploaded into the cloud, and credential protected to access them. This means that they are also protected while they travel through the network, giving us data in transit security. We first download the Azure dataset, and we show that it is actually an encrypted blob. And then do the same for AWS. Now we decrypt the dataset. Here is where attestation takes place. We need to connect with Trusty and ask a key to decrypt the dataset. Under the hood, the process ensures that the hardware and software have not been tampered with, and if everything is successful, it means that we have data in use security, meaning that the memory is encrypted by the hardware. Once we got the key, we use it to decrypt the datasets. Lastly, we load the dataset in memory and feed them to the model, which will analyze them and tell us if there are fraudulent transactions. This concludes our demo. Thank you and goodbye.